This video is brought to you by Awesome Sharp School. You can go to awesomesharp.school to find out one of the largest catalogs for iOS development videos. Let's go ahead and check out some courses. You can see that on Awesome Sharp School, you can find courses about MVVM design pattern, core data, MV pattern, full stack iOS development, reactive programming, even Swift data and server-driven UI, Create ML, test-driven development, Reality Kit, and many more. And there are also workshops. These will be live workshops accessible to everyone. The pricing is just insanely low, only $50, and you get 2 to 3 hours of live workshop on Zoom about Vapor, and then you have Swift data fundamentals and even unit testing. So go to awesomesharp.school and learn iOS development. So let's go ahead and start our first SwiftUI project. I'm going to launch Xcode and then select Create New Project. And you can see that there are a lot of different templates that you can choose from. Since we're just working on an iOS application, I'm just going to select the app itself and that's it. But if you're working on a game, you should probably select game and so on. Let's go next. The product name, we'll just call it Hello SwiftUI. And over here, the important part is that in the interface, you will select SwiftUI. The other one is storyboard. But since this course is about SwiftUI, you should select SwiftUI. Language will be Swift. And next, where do we want to place this project? I'm just going to place it on my desktop, but you can place it anywhere you want. So this is what it looks like. You can see that we have a couple of different files added in our project. This is our main application, meaning the actual view that will be displayed on the screen. So this is the content view. All right. And on the right hand side, you can see it's taking a little bit of time, but this is going to be the preview. So SwiftUI is a declarative framework, meaning you simply declare what you want to see and it's going to render it for you. But before we do that, let's go ahead and take a look at the app file. Now this app file is the starting point of your application, and that's why it's marked with main. When you launch your SwiftUI application, this is your main application, or this is your main entry point. The app is simply, if you simply check this out, is simply a protocol. All right. And it's going to go to the body and going to render the view that we are telling it to render, which in this case is content view. Now the window group over here can be important if you're building like a Mac OS application and so on, but the content view is our view that will get rendered on the screen, that get displayed on the screen. Let's go ahead and take a look at the content view, keeping in mind that all the code that we see right now is actually written by default, right? We didn't really write any code. And we can see a couple of different things. The first thing we see is the name of the view. So what's a view? Well, view is something that gets displayed on the screen. That's a view. It is conforming to the view protocol. That's the important part. If the content view does not conform to the view protocol, then content view is not a view. So it conforms to the view protocol. And let me go ahead and remove all of this stuff so we can kind of like do it from the beginning. There we go. So we'll create a struct, content view, and all of the views that we will create are actually value types. So they are structs. If I try to create this as a class, then you will see that it doesn't like it. All right. You can also see over here the error is telling you that the view needs to be a value type. So we'll have to make it a struct. Now, even though we have created a content view, and again, you can name this anything you want. You can call this my view, your view, customer view, whatever. The important part is that if you want it to be displayed on the screen, it must conform to the view protocol. But right now, we're not conforming to the view protocol, and that's why the error is actually telling you. So how can we conform to the view protocol? Well, we can go ahead and implement the body property. Okay. So what exactly is this body property? The body property is going to tell SwiftUI that what needs to be displayed on the screen. So whatever this body property returns, that is the control or the component or the view that gets displayed on the screen. And you can see that we're using some view over here. So this means that anything that we are going to return from here, it must be conforming to the view protocol. So if I want to simply display a text on the screen, so I'll simply use a text view, which is simply called text. And you can see that as soon as I type something over here, it's immediately refreshed in the Xcode preview. So that's a really good thing about SwiftUI, is that it's kind of like live. Now, depending on your machine, if you have a slow machine, then Xcode previews are going to take a long time to, to render, to load. But on a faster machines, especially with M1s and M2s, that MacBook Pros, they are very fast. So we're currently just returning a single view right over here, which is a text view. Over here is something different. Now, since we are using iOS 17, you can see the different part of it. This is known as a macro. And this macro, a macro simply means that it's going to generate some code. And it's called the preview macro. So preview macros are already included in iOS 17. And macros, there are a lot of other macros that are also included, but the preview macro is the one that allows you to generate the preview. If I remove the preview macro, then the preview is gone, as you can see. So let's go ahead and get back the preview macro. So the preview macro is simply to create the preview. And what preview we want to create? Well, we want to preview the view called content view. So it's going to render this particular view so that we can look at it in the Xcode preview. So previews are important for the developer's perspective because you are able to see live what's going on. If I go ahead and change Hello World to something else, you will see that the preview is changing. And that is really good because it's giving you a live indication of what exactly is going on. So that's really, really useful. All right. Okay, so at this point, you have seen that how the SwiftUI kind of like a very basic structure works, and I'm sure you're super excited because it's very different from UIKit. And one thing that you will recognize is that when you're using SwiftUI, you can create your user interfaces very, very fast, as we will learn in the future. All right. So in the next lecture, we'll be looking at how we can add multiple views, and we will be using VStacks and HStacks, and then eventually we'll be learning about using images. Now let's go ahead and see that how we can customize the text and also combine different views using stacks. So in the last lecture, you learned some of the basics of SwiftUI, and we created a single view, basically the text view. Obviously, the text view is inside the content view, so we can add multiple views also inside other views. So if I go over here and add another view, let's say I call this second line, and the first one I should call it, first line. So I can do that also. You can see I can add multiple views. You can also use VStack, meaning a vertical stack. So anything you're going to put inside the VStack will be arranged in a vertical manner. So you can see the first line is getting first, and then right after that, the second line is coming. And since it's a vertical stack, it stacks the item vertically. So one, and then the next one. All right. The vertical stack does have some other features also, like you can provide a little bit of spacing between them. So you can see right now, each of the items will have spacing. You can have more lines. You're not limited to 2 or 3, but here we go. We can add like a third line or something if I want to. There we go. And each line or each view inside the vertical stack will have 20 points of spaces between them. If I go ahead and add more spaces, let's say 60 points, then you can see its effect. Great. So that's what the vertical stack is used for. The vertical stack is just one of the stacks. You can also use a horizontal stack. So if I want to arrange items in a horizontal fashion, one on the left, one on the right, then that is a job for a horizontal stack. I can go ahead and create a horizontal stack inside the vertical stack, or I can create it anywhere I want. But let's go ahead and create it inside the vertical stack. And we're going to go ahead and add another text view. We'll call it left, and we'll call it right. There we go. You can see that horizontal stack, which is represented by H, horizontal, it allows you to add the items left and right. Now, each of these items are very plain. They don't really have any style associated with them. So if you want to add some style to them, you can by using font, foreground color, and so on. So let's go ahead and check out the foreground style. For the foreground style, we can simply go ahead and say different color. Let's say that we want cyan color. So now the text color, as you can see, for the first item is cyan. But if I go ahead and change the foreground color to something else, let's say that if I want this color to be green, so I can apply those things. All right. Apart from that, you can apply the foreground style on the VStack itself. So I can go ahead and say orange. This means that all the different views who don't have their style defined using the foreground style property or the foreground style view modifier, that's what they're called, then they will use the orange style. So if basically the view uses the style or the view modifier, whatever they're doing, the view modifiers can be anything that is closest to them. So if we are taking a look at the text over here, the closest view modifier attached to it is a foreground style of cyan, then it is applied. There are a lot of different controls over here, like the different text views that don't have the foreground style applied to them. So they're just going to use whatever is applied on the parent, which is the VStack, and we're applying the orange style. You can also apply different fonts. So I can go ahead and say over here, large title. Now this is going to be kind of large, and you can see that they do have different things over here. They have title, large title, title 2, which is a little bit smaller, title 3 is even a little bit smaller more. They also have like a font weight. So I can say font weight, and then I can say heavy. All right. So all of these features are given to you, are available to you for using with SwiftUI. And you can see that how easy it becomes to style different elements on the screen. Now, right now we have been playing around with VStack, HStack, and text views, but there are other controls also, like images. So in the next lecture, we'll be looking at how to display images using SwiftUI. Now let's go ahead and see that how we can add an image. In order to add an image, the first thing we will need is an actual image. So I've already downloaded an image. Let me go ahead and refer to that image. It's right here. And let's go ahead and import it in our app. And the way that you import it in your app is that you put it inside the assets. So I can go ahead and just put the image inside the assets. And I can also rename this. So I can say Costa Rica. Great. Let's go ahead and delete the image from over here so that it is still inside the assets. That's good. You can obviously use any image that you want. I'm just going to go ahead and use this image. This image was provided by from Unsplash, so I'm just going to go ahead and add the credit. I don't think I can pronounce a name for this person, but I'm just going to add the link to that. So the credits to the image is right there on the top. Great. So how do we add an image? Well, you may have already guessed, for the text we use the text control or the text view. If you want an image, well, there is an image view. And you can see that the image can contain or come from many different places. But what we want is just to get the image itself. So we can simply go ahead and pass in the actual name. So name of the image. I think our name is Costa Rica. That is the name of the image. And you can already see that the image is appearing. That's a good thing about Xcode previews, is you can already see it's working. The image is actually too big, so we will use another view modifier, resizable. And when you say resizable, it's automatically going to resize it. But still you can see that the image is not really resized correctly, right? I mean, it's a little bit stretched out. In those cases, you can use aspect ratio. And you have many different options like fit and fill. The fit option is going to get the image and try to fit it proportionally, as you can see. So here is how we are adding an image. Now you can play around with it. You can add multiple images. You can also go ahead and change the shape of the image. So I can go ahead and say clip shape, and I can provide over here a circle. So now the image is actually clipped into a circle, which is kind of cool. That's how easy it is. So all of these things that we're using, as I mentioned earlier on, all of these are called view modifiers, which modifies the view. Now we can go ahead and clip it. If you don't want the circle, we can always clip it to a different shape. Let's say a rounded rectangle, and we can provide a different corner radius and different style. So corner radius 25 is fine, and the style is continuous is fine. Okay. There is another tag that you can use, a view modifier, which is called padding. And padding allows to put the spacing from the outside. You can see a little bit of padding now going on over here. That is the padding that we have added. Padding can be applied to any of the views that you have. So if I want padding on the text view, let's say the first one, I'll simply go ahead and add a padding modifier. If you don't pass anything to the padding modifier, then by default it adds padding on all the sides, and with a specified number. I believe it's like 13 points or 11 points, something like that. But if you want to modify it, you can always do that. You can say padding, and I want to apply padding of 25 in all the directions. But sometimes you only want to apply the padding in one direction, meaning you only want to apply the padding on the top. So I can say padding on the top 20. And now you can see a little bit of padding is applied, but only on the top. If you want to apply padding on the top and the bottom, then we can also pass in the bottom. So now the padding is applied on the top and the bottom, and so on. Now, just like the image control over here, or the image view over here, there is another one called the async image. The async image, as the name suggests, can be used to get an image from a URL. So you would use this when you don't have the actual image inside your project or inside your assets folder, but the actual image is in the URL, meaning you do have the URL for the image, but you have to download the image. So let's go ahead and see that how we can achieve that. The first thing it needs is a URL, obviously. So we need to get the image from a URL. So I'm just going to go ahead and use the same image. I'm just right click and I'll say copy image address, and hopefully we'll be able to use this URL. You need to provide a URL over here, so not a string. So I'm just going to put it over there. I know it's a big URL, and I will forcefully unwrap it because it is going to work, because I just know that this URL works. We just copied it from somewhere. The content part is going to give you the image. Okay, that is something we have to do something over here. So the actual image, we will simply say resizable, so that it again resizes after it is downloaded. And the placeholder is while the actual image is being downloaded, what to display. Now this is kind of like up to you, whatever you want to display. I'm just going to display over here, like some sort of a text view saying downloading. All right. And there we go. For a brief second, you were able to see downloading, right? And once the image was downloaded, then you're able to see the second image. Let me go ahead and do it again. I'm going to just refresh my Xcode preview. And the way that I refresh Xcode preview, just type something in my code, like a space, 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 and then save it. And you'll see downloading, and then you can already see the image. Space, 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 downloading. There we go. Obviously, for this particular view, text, if you don't want to use a text view, you want to use an image over here, you want to use something completely different, you can definitely do that. That is up to you. The SwiftUI also comes with a progress view, so maybe you want to use a progress view. You know, it really depends on your preference. So I can say over here, downloading. So now I've added a progress view, and it happens very quickly, right? So if I again press space, 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 progress view, it's downloaded super quickly. So we can see it for less than a split second, and then obviously the image is downloaded and getting displayed. So if you already have the image in your project, use the image and point to that particular image. If you don't have the image and you have to download it from a URL, from a resource, then you should use async image. All right. So there you have it. We have learned a lot about the basics of SwiftUI in this section. In this section, you'll be learning about how to build a list and perform navigation in SwiftUI. So let's go ahead and get started. We're building a simple hiking application where we can display some hiking data like the name of the hike, the picture or the image associated with the hike, and also the number of miles for that particular hike. In the assets folder, I've already added 3 different hikes. And images are associated with them like SAL, TAM, and TOM for short names for these different hikes. Now, if we want to display these hikes information into our application, the first thing we should do is represent the hike with the model. So I'm going to go ahead and create a new group. I'll call it models. And inside the models, I'm going to add a new file, and we'll simply call it hike. Great. Now, our hike contains the name, the image URL, and also the number of miles. So I'll simply go ahead and say hike, name, which will be string, photo of the hike. You can use image URL, but the URL is local, so I'll just call it photo. And also the number of miles, whether it is 6.5 miles, 3.2 miles, and so on. So this structure or struct is going to represent a single hike. Now let's go to the content view and see that how we can display a list of hikes in a list, which is a SwiftUI list control. Now behind the scene, the list control uses UI collection view, which is from a UI kit. But we're only interested in learning about how all of these things are hidden from us, and we can simply use the list control itself. So let's see how we can do that. The first thing we need is a list of all the different hikes that are available to us. So for that, inside the content view, I can create a local variable called hikes. And you can already see that this is a local variable and it is hard-coded all of these different things. Let's call this photo because we named our image URL as a photo instead of the image URL. And now we have hikes array, which consists of 3 different hikes. You can see that each photo is pointing to the exact name that we have given in our assets folder. The next thing is how do we display the hikes? Let's go ahead and say list hikes, and When we use a list in SwiftUI and we pass in an array, which is hikes in this case, we can access the individual item of the list or of the array by using this closure. We can get access to the hike. And I would say that let's start with simply displaying the name of the hike by using the name property. Now, if we try to build this application, you can already see that it's complaining. It's saying that the hike needs to conform to identifiable. So right now, when we created our hike struct, it is not conforming to identifiable. And identifiable is needed by SwiftUI to make sure that all the elements that it's going to be creating will have some sort of uniqueness to it. So it gives it some sort of identity to your UI elements. So I'm going to go ahead and try to conform to identifiable. Over here you can see that since we are trying to conform to the protocol identifiable, we need to implement one of the required things, which is the ID. And this has to be unique. So I'm just going to go ahead and assign it a UUID, which will be unique. Let's go back to our content view. And now you can see that the error goes away and also our hikes are displayed. This is great. I mean, think about all the code that you had to type when you were using the UI table view or UI collection view in UIKit. And now with only a couple of lines of code, you were able to build a nice list. Currently in our list, we are not displaying the images. How can we display images? Well, we will need to use the image control. I'm going to go ahead and press Control click and then simply say embed in edge stack, which is a horizontal stack. And the reason I'm doing that is I want the image on the right hand or the left hand side of each of these text. Now I can use an image and I can pass in the photo, which points to the image. As soon as I do that, I can definitely see the image, but the image is too large. We need to resize it. So let's go ahead and say resizable. Okay, and we can also say the aspect ratio to be fit. Okay, that's fine, but I think we can resize all of these pictures to a particular frame. So we can give it some sort of a height and width. Let's start with 75 and height of 75 also. Now, if you don't like this, you can definitely change that. If you want to do it more like 100 by 100, you can also do that. If you want your pictures to have a rounded border, you can use clip shape. And you can pass in a particular shape that you want. You can pass in the circle. Or in our case, we can go ahead and pass in the rounded rectangle with a particular corner radius. There we go. Now you can adjust this particular corner radius to 16 or something like that, and then it will work better. Make sure that you apply it at the correct point. So let's go ahead and apply it before doing the actual framing, and now you can see that it looks much nicer. If 16 is too much, then go ahead and give it a different one, like 10 or something. Another thing that we want to do is we want to make sure that all of these texts that we're displaying is kind of like aligned on the top. In the edge stack, we can always go ahead and say alignment and then to the top. Well, that goes on too much on the top. So let's see what other things we have over here. We have top, we have first baseline, we may have like the last baseline. So choose the one that actually works for you. Definitely not the last baseline. We can have center and all that stuff. So I think by default, we're just using center, which in our case is fine. What about if we remove the height of this? That looks much better, definitely. And now if we say top, let's see how far it goes. Okay, now it looks much better. All right. If you want to also display the miles associated with each of the hike, we can also do that. So let's go ahead and wrap our text into a vertical stack, and we will simply adjust some miles over here. Hike.miles. Now, since miles is in double, we will have to go ahead and use our technique over here, which is hike.miles. It's giving us 6.000 something. So these are the miles that is giving. But if these are the miles, maybe we can even format it in a much nicer way than just saying 6.000 miles. So how can we do that? If you need to format your miles and remove all the extra zeros, you can simply go ahead and call formatted. It's going to format it nicely, going to only pick up one of the number after the actual decimal point. And after that, if you want to make sure that it is aligned correctly, then we can use alignment on the V stack, and we can say leading, so that kind of everything moves to the left. And since these are miles, we can simply go ahead and say miles also. But in actual applications, you should take into account that your application can be used with different regions. So maybe they're using kilometers and all that stuff. That is a different story. We are going to look at it maybe later in the course. But right now, since our miles or hiking.miles property does contain miles, we're simply going to say miles. But again, in actual application, you should always make sure that you are displaying the information according to the locale of the user. So if I'm in some other part of the world where they use kilometers, then you should use kilometers instead of miles. So this looks pretty good. With only a few lines of code, we were able to create a great looking user interface. This particular user interface would have taken us a little bit more time to create in UIKit, but now with the power of declarative syntax with SwiftUI, we can do it much quicker. Now the next thing that we need to do is we need to implement navigation. So in the next lecture, we're going to learn about navigation stack and how it can enable us to perform navigation. Now let's go ahead and see that how we can add navigation to our hiking application. Now before we do that, let's go ahead and see that how we can improve our existing app. Currently you can see that we're going through a list, and all of this portion, which is the at stack, this is basically the cell that gets displayed right over here. Maybe all of this we can extract out, and we can create a reusable control for that. If I right click on at stack, you can see one of the options is extract subview. So let's go ahead and extract it. Our subview is extracted. It is called extracted view. We can go ahead and change the name over here to something that tells a story. So I'm just going to go ahead and call it hike cell view. This means that I need to change extracted view to hike cell view also. If I try to build this application, it's not going to build because of all of these errors. It's basically saying that inside hike cell view, you're using hike. But where is this hike coming from? Since this is a separate struct, it does not have access to anything called hike. What we can do is we can allow the hike cell view to be passed in. So hike, and we pass in the hike. So the value of the hike is going from the list closure, and every single time the list is going to run, it's going to run this closure for every single cell and going to pass the hike to the hike cell view. Now we can update our hike cell view to support that. There we go. If you run your application and you can look at it in the preview, everything works as expected. So nothing really has actually changed. So this is one of the ways to extract out and to create smaller subviews. Keep in mind that when you create views, these are very lightweight, meaning you can create as many views as you want. And you can use your views to nicely structure or compose your application also. Now let's go back to the navigation. One thing to note over here is that if I go on Xcode Previews and click on any of these options, it doesn't really work because there is no navigation. So how can we add navigation? In order to add navigation, we need to add something called a navigation stack. So let's go and add navigation stack. So I'm going to wrap everything inside the navigation stack. The navigation stack is going to be kind of like that if you're putting your views inside the navigation controller. This means that once the things are inside navigation stack, they can use the navigation features. Let's also go ahead and add some sort of a navigation title, like hikes. You can see the navigation title appearing in the navigation bar. Great. Currently, we still cannot really perform any navigation. If you want to perform navigation, you are going to use navigation link. Navigation link comes in separate, many different ways. You can see over here that you can use a navigation link that relies on the title and the value associated with it. You can use a value and a label. You can use a destination and a label. There are many more. What I'm going to do is I'm going to use navigation link with the value and the label. Now the label is something that gets displayed on the screen, which means I can simply pass in the hike cell view. And the value over here needs to conform to hashable. This means that our hike struct needs to conform to hashable, which is simple because we can always go to the hike struct and make sure that it is conforming to hashable. There we go. Let's go back to the content view. So what is this value and how does that work? Well, first thing you note is that as soon as we wrap our hike cell view inside the navigation link, these things, indicators, come into play. If you click on any of these things, it's not going to work. You can see the row or cell that I'm clicking or tapping, it's still not really navigating. So one way to navigate is to implement navigation destination. Now here's where the things get interesting. Over here in the navigation link, you have provided the value to be of type hike. This means that if the navigation destination is for a type hike, then this particular navigation destination closure is going to get fired. So this means that if I go ahead and create a navigation destination for integer, then when I click on the hike cell view, it's never going to go to the integer because the value that we passed in was hike. So in order to listen for those values and perform navigation when those values are selected, we need to use hike. Hike.self means the type of hike. And over here in the closure, we get access to the actual closure, meaning the actual hike. So basically this object. Once we have the hike object, we can go ahead and go to a destination view, which in this case can be as simple as a text view. Now if I try to perform navigation, you can see it's working correctly. Each time I click on any of these different hike options, it takes me to a text view and shows the information about that hike. Now, if I change this, once again, if I change this part and I say, well, this is a navigation destination, not for a hike, but for integer, meaning the value has to be integer, then nothing is going to work. If I tap on it, nothing happens. Because the reason is that since we have provided the value to be of type hike in the navigation link, we need to provide the navigation destination for the same type. So, hike. Another thing to note is that it's always a good idea to add navigation destination at a little bit more top level. So, one thing you note is that I'm not going to put this navigation destination over here, because then you're inside a loop and you're adding this navigation destination inside a loop. That's not a good idea. It's not going to work correctly. So make sure that you put the navigation destination a little bit at a higher level so that the navigation link will know about the navigation destination. So let's go ahead and type over here hike.name. Once again, it started working. Great. Now on our detail view that we want to go, right now it's simply displayed a text view because we are using a text view right there. But we want to go and show you the detail screen. So maybe we can create a new screen, call it hike detail screen, and take them there instead of going to the text view. So let's go to the next lecture and learn how we can implement a hike detail screen. Now let's go ahead and work on a hike detail screen. I'm going to go ahead and add a new view, a SwiftUI view, and I will call it hike detail screen. This is where we will display the details of the hike. Let's go back to the content view. Instead of using the text view over here, we can go ahead and replace it with the hike detail screen. Now keep in mind that when we are showing the details in our current application, it will look exactly like the information that we are displaying in the main screen, and the reason is that that's the only 3 pieces of information that we have. But if you had other information, then you can display in the detail screen if you want to. The hike detail screen can work if you pass in the hike to the detail screen. So this means that there is a dependency for the hike detail screen on hike. So let's go ahead and make sure that we are actually passing in the hike. We'll go back to the hike detail screen and update the hike detail screen to have a dependency on the hike. As soon as we add that, the preview complains. The preview says, well, you can't do that because hike is missing. You're trying to create an instance of hike detail screen, but that has a dependency on hike. So you need to pass in the hike. So we'll pass in the hike with some sort of a name, photo, and miles. I can go back to the content view and get copy of one of those hikes. Let's go ahead and paste it over there so that our preview can work. Great. The next thing that we want to do is we want to make sure that our hike detail screen shows us the image, the name of the hike, and also the number of miles. For this, I can use a vertical stack or a V stack. I'll use an image and I'll use hike.photo. This is going to show me the photo of the hike. The photo is too big, so let's go ahead and resize it. And also make sure that the aspect ratio is correct by passing in the fit. Much better. The other thing we want to do is to show the name of the hike, which we can get from hike.name. Great. We can also use a different font if we want to, like probably title. And finally, we can display the hike.miles. But as you can see, the miles is double, so we can't really use it like that. Let's go ahead and change it, hike.miles, and format it. And we'll also say this is miles. Great, now it's looking much better. If you want to push everything on the top, you can use a spacer. Spacer is a flexible space, and that can push everything on the top. We can also go ahead and try to add a navigation title to see how the name will look in the navigation title. But one thing to note over here is that the navigation title doesn't appear. And the reason is that the navigation title can only appear when your control is wrapped up in the navigation stack. But the control is wrapped up in the navigation stack if we go to the content view. You can see that it is wrapped up in the navigation stack. But we're talking about a different screen. We're talking about the hike detail screen. So we don't really want to go over here and wrap this also with a navigation stack. Navigation stack is the root when it is already available in the previous view. So we don't really want to add this to every single view. So if we can't really add a navigation stack over here, how do we preview the navigation bar? Well, you can just go ahead and update the preview and add a navigation stack in the preview. This means that it's not really going to be part of the code itself, it's just part of the preview. And now you can see that your navigation title appears correctly. Let's go back to our content view and test it out. I'm going to click on the second one, and you can see that it appears correctly. Great. One of the things to note over here is that the title is a little bit truncated. Now, for you, it depends. Do you want to do something about it, or do you want to leave it alone? Let's go ahead and see what options do we have when the title can be truncated. If you want to resize your navigation bar, so instead of using the default one, we can also use the navigation display mode to be inline. Inline simply means that it's going to not display the large size text, it's going to display the smaller one. And now we can go back to the content view and we can check. Okay, looking good. And you can see that now the large name kind of fits correctly. Great. So it looks like we have added the navigation to our application correctly. Our next task would be to add a little bit of animation, like a tap gesture on the image itself. So let's go to the next lecture and see how we can accomplish that. Now let's go ahead and see that how we can add animation. So where do we start? Well, we wanted to add animation when we click or tap on the image. And we want the image to grow a little bit bigger and kind of take zoom in kind of effect. So let's go to the hike detail screen, because that is where we wanted to tap on the image. On the image itself, we can add on tap gesture. And when we tap on the image, this particular closure gets fired. Now, once we tap on the image, we kind of like want to zoom in, but once we tap on the same image again, we want to zoom out. So we want to toggle the zoom factor. For this, I'm going to go ahead and add a state variable, private var. We'll call it zoomed. It will be a Boolean value indicating whether it is zoomed or not. And now we can go ahead and change this zoomed toggle. Great. This means that when we tap on the image, it will be toggled to true and false, true and false. And based on that, we can change the content mode, the aspect ratio, between fit and fill. So we can say over here, if it is zoomed, then we will use fill, else use fit. This should be zoomed. Great. And now you can see that when we tap on it, it zooms in and zooms out. But we can also add a little bit of animation to it, just by wrapping all of this when we are changing the state with a with animation block. And there we go. Now we have added nice animation with only few lines of code. And there you have it. We have built a basic hiking application. We learn about the SwiftUI list. We learn about the navigation to the details screen. We learn about the refactoring and also a little bit of animation along the way. One of the main concepts behind SwiftUI programming is the concept of state. You can think of state as a storage for the data, and using that data, you are going to update your user interface. So your user interface is going to reflect what's in the state, and they have to be in sync to get SwiftUI working correctly. So let's take a look at an example. Let's say that if we want to create a simple application for counter, meaning a user can press a button to increase the value of a counter. We may go ahead and create just a private var variable like count and initialize it with 0. That's fine. Next, we need a button. So let's go ahead and add a button. And the button will simply say increment. We also need a way to display the counter value, which we can use the text view to do that. We can also change the font size to be large title, so it's a little bit larger. Great. Now the job of the button action, or the click or the press of the button, is to increment the value of the count. If I go ahead and update the value of the count just by adding 1 to it or incrementing it, you can see that it is complaining. And the reason it is complaining is because you are in a struct. And in a struct, it is not really mutable, meaning you can't really just change the properties like this unless you are inside a function that is marked with mutating and all that. Even if you go ahead and add a function and perform mutating, it's not going to work. So in order to do that in SwiftUI, you simply add the state property wrapper. The state property wrapper is going to allow you to increment the value of the count. The value will be stored somewhere in memory so that we can get it back when our content view or this particular view re-renders again. So now let's go ahead and press on the increment button, and you can see that the count is actually incrementing. So this means that when you are incrementing the count, which is by pressing the button, the value of the count is incrementing, and whenever you increment the value, the text view, because this is the only view that is using the count to display the count, gets re-rendered. This means that if I go ahead and add another view over here, and I say that view will be called Hello World, when you increment the count, since this text view is the only one that is using the count, this one will be re-rendered. But this particular text view, nothing is going to happen to that. It's going to stay as it is. And this makes SwiftUI works very, very fast because SwiftUI knows the dependencies and SwiftUI knows that which views needs to update, and it is smart enough to only update those views. So this is the concept of state. In the next lecture, we will take a look at another example of how different controls that are provided by SwiftUI also use the concept of state to work. Let's take another example of state. I'm going to go ahead and remove the count and remove most of the stuff from here, replace it with just the text view. Okay. So let's say that we want to create an interface where we can allow user to toggle between two different states, true and false. In those cases, we can create a state variable and we can call it isOn. Obviously, the name of the variable is completely up to you, and we can initialize it with a Boolean value initially of false. Now, there are a lot of different controls available in SwiftUI that you can use at this point, but one of those controls is called the toggle control. And the toggle view is going to take in two different things. It can take in, you can see, this is the one, isOn, that's just the name of the label, and then this has to be a bindable. And state, whenever we declare the state, that is the bindable. Right? So, but there's a special way to pass that. So let me show you. So if we say toggle, we can use $, and then we can pass the binding for this state. So isOn binding. And then for the label, whatever label that you want to display, I'm just going to say off for now. And you can see that it is being displayed. Now, if you wanted to control the size, you can simply go ahead and say fixed size over here so that it removes that extra spacing and only fill the contents that is necessary. So let's take a closer look at what this is doing. When we pass binding, which is indicated by this $, what happens is that anytime you are going to change the state from true to false, like if you're going to switch back the state, that value, whether it is true or false, will be updated in the isOn variable. So initially, the isOn variable is false, right? So that is why if I go ahead and run it again, I'm just going to go ahead and save it. So you will see in a moment. There we go. So you can see that since we declared isOn to be false, the toggle is right now off. If I switch it, it's going to turn on. Now look what happens if I set the isOn value to be true instead of false. And you'll see that it will be, initially, it will be turned on. All right. So this is controlling, the state is basically controlling the actual appearance or the actual value of the toggle or the actual state of the toggle, right? And whenever you toggle between on, off, this value isOn changes due to binding. So this particular value isOn is toggling between false and true, true and false. Now, one of the things that we can do is whenever you change this value, whenever you're switching the value, turning it on, turning it off, this body is re-evaluated. Re-evaluated simply means that SwiftUI is going to take a look at this body and it's going to go through the controls and find out that which control needs to be re-rendered. But right now, if you look at all the controls, not really any control have to be re-rendered because none of them are using isOn. isOn is simply tied up to the toggle. But what we can do is we can use this text and we can make sure that the value not always say off, but it will toggle. So if I go over here and say isOn, then we can go ahead and put the value to be, if it's on, then you can say, on. If it's off or else, it will be off. All right, depending on what interface that you want. All right. So now it's on, now it's off. Now it's on, now it's off. So you can see the value is now switching based on what we're trying to do. But this is not only limited to changing the value of the text, because when the state changes, the whole body gets reevaluated and you can have other conditions also. So let's say that if I am on the VStack and I extend the VStack to cover the whole screen, I say maximum width of this VStack, vertical stack, is infinity, and the maximum height is also infinity. And then let's go ahead and say that the background color, I'm just going to put green over here. Okay, so you can see the whole thing turns green, right? But based on this value of on and off, we can change. Actually, green might not be a good color for us because, you know, everything is green kind of. So I'm just going to go ahead and go with white for now. Or you can just go for dark, which is black. There we go. All right, so we can now turn on or off, on or off. If you also want the text color to be different, we can use foreground style. And we can pass in, let's say, white over here. There we go. Okay. So what we want is when we turn it on, we color it yellow. And we can do that. If is on, then go ahead and return yellow color, or else return black color. So if it's on, yellow. If it's off, black. So now you can see that how the state is actually working, and whenever the value of the state is changing, we are making sure that our thing is, our user interface is sync with it. So that's the important part. All right. So this was another example of state, just to give you an idea. And make sure that you practice state a lot, because state is one of the most important things in SwiftUI, because state makes sure that your UI is up to date, and whatever the value is in the state, it's sync with the user interface. Now, there are multiple ways of managing the state, and that is what we're going to see later in this section when we learn about binding and also environment object. Now let's go ahead and take a look at how state works when you are using a list in SwiftUI. So what we're going to do is we're going to create a very simple kind of interface where a user can enter the name of their friends, and we are going to maintain a list of their friends, and that's it. All right. So again, I'm going to remove most of this code. We don't need all of that. We'll start with VStack, and we will use a text field because that's how they're going to be entering the name of their friends. And you can see that the text field, the first one is the title key, which is going to be kind of like a placeholder in the text field. But the second one is, again, a binding. So this means that whenever you will write in the text field, it will go to a state variable or whatever the variable that you're using for binding. So we're going to use state, and I'm just going to say name, assign it to nothing. We'll just assign it to like an empty string. And then we can put this name as the binding. So when you want to access the binding, you always use a $sign and then name. So this means that whenever you type something in the text field, it's going to go automatically to the name. All right. And you can see our text field over here. If you want, we can go ahead and add a different text field style. We can call it rounded border, and we can also add a little bit of padding to our VStack. We can also use the spacer, which is going to push the text field up. So there we go. You can see the text field. Now, whenever we type something in the text field and we press enter, we want that particular information, the name that we entered. Let's say that if I entered John and I press the return key, I want that name to be added to a list. So I'm going to go ahead and say create a list called state. We'll call it friends. It's going to be a string array. And whenever the person submits the text field, which is this basically means that they perform an action, they press the return key while their cursor is inside the text field, the submit is going to get fired. We can get the name because this is a variable that contains the name. So whenever you're typing something in the text field, that thing that you're typing in the text field, the text is populating the name binding or the name state variable. So we can say friends.append name. All right. So whatever is in the name, you append it to the friends. And now I can go ahead and also kind of like reset the name so that we don't have to remove it manually. It will automatically be removed from the text field. But it's already added to the friends array. The final thing that we want to do is want to display the items of this array. So I'm going to use a list view over here, list, pass in the friends. I'll get access to the friend. Now keep in mind that the friends array contains basically a list of string. So friend is basically a list or just a particular string. Now whenever we use something like friends or array over here, a collection, we have to make sure that the item of that collection, which in this case is a string, is conforming to identifiable. So for now, since this is not our custom type, we can kind of ignore that, and we can say that the ID will be self. Self basically means that the ID over here basically means that each item of this list will be identified by this identifier, meaning ID, and self over here means the content of the friends array. So those content, which is simply string, they are hashable, and you can only provide the values that are actually hashable over here. So that's why we're providing self, which is each item of the friends array. Now, having done that, let's go ahead and type a name. And I'm going to go ahead and press enter. And you can see that as soon as I press enter, that name is added to the list. And once that name is added to the list, the view itself is then recalculated, reevaluated. And then we find out that, oh, the list is actually using friends. So we need to render the list. And that's what's going on. The list is getting rendered. So if I go ahead and add more names, you can see that the names are being added successfully to our list. So this is how you can use SwiftUI and state and list together. And this can be a very common operation because you know that list is actually used in most parts of your iOS applications. So if you want to populate a list, this is one of the ways that you can do that. Now, in the next lecture, we can take a look at how we can perform filtering of the items that we have. All right, so let's go to the next lecture. Now let's go ahead and take another example of state. Now you can see that I have changed a little bit of things over here. The first thing I've done is that I've created a state array called friends, and it just consists of a couple of different names, couple of different friends. And I've also used a navigation stack in the preview. And what the navigation stack allows you to do is that it will add a navigation bar on the top. So if I want to go ahead and add some sort of a title, I can use navigation title, and I can now provide a title. Now keep in mind that we have added this navigation stack, which from a UI kit point of view is kind of like a navigation controller. But when you run your app, the navigation stack will not be there because we're only adding it to the preview. If you wanted to add to your actual application so you can run it on a simulator and your device, then go to the app file and make sure that you add a navigation stack here. So I'm going to go ahead and say navigation stack. There we go. And now we have the navigation stack. If you run your application on the simulator or even on your device, then you will have the navigation stack. The navigation stack over here is just for the preview. So one of the things that we want to do is we want to ability to search. Now you can see that we do have a list, but I have removed the text box or the text field. Because we don't really want to use or have to use the text field, we can actually use one of the features of SwiftUI, which is called searchable. So searchable is going to simply add a search bar with a text box automatically on the top of the list. Now the requirement over here is that you are using the navigation stack because that is where the bar will be added. Or well, below that, but it needs a navigation stack. Searchable, as you can also see, needs a binding of a string. So we don't really have that string, so let's go ahead and create that. There we go. We created the string, and now we can pass that string, which is search, as a binding. And when we use binding, we always use a $sign. So there we go. And you will see that now a search bar is added. The other thing we can do is we can customize the look of the list. This can be done by simply supplying the list style and using the plain list style. So you can see that now it's plain, it's not like indented or anything. It's nice and plain. Whenever we type something in the search, so if I type some sort of a name over here, it's going to go into the search bindable property. But what we want to do is we need to capture, when we are trying to search for something, we need to capture whenever the person is typing and at the point of when they're typing. One of the modifier, the view modifier, is called onChange. And onChange is going to get fired whenever you are searching, whenever something changes. And over here, for the equatable, you can provide the thing that you're looking for to change. So I'm just going to say search. When that changes, then go ahead and fire this closure. So onChange is now on the list, and it's saying that whenever the property search is going to change, then I'm going to go ahead and fire this particular closure. Now there's really nothing in the closure, but this closure is going to get fired anytime the search is going to change. The search is going to change every time I'm going to go ahead and type something in the text box. So the search is going to change. Inside onChange, we can perform the filter. But before we do that, we will create another list which will consist of the filtered friends. You can see that that particular list is empty. There's nothing going on in there. So on the onChange, we will go through the main list. So friends is our main list. We will perform the filter, and the filter will be performed if that particular name contains the search criteria. So if the name that is already inside the friends array contains the search, whatever we are typing in the text box, then we are going to go ahead and get a new array. We will assign it to the filtered array or filtered friends, and that is what we're going to use. Now let's go ahead and start using filtered friends instead of friends. Great. Well, the first thing you will notice is that the list doesn't really display anything. And the reason is that the filtered friends is initialized to be an empty array. So right now you're looking at an empty array. It doesn't really have anything. What we want to do is when this particular VStack is rendered or appeared, we can assign the filter friends the value of friends, just so that we have some initial value. This can be done by using onAppear. OnAppear simply means that when that particular view actually appears. So when this view appears, the filter friends will be applied or will be assigned the value of friends. This is just the initial value of filtered friends. And now you can see that we are getting a list of friends. Let's go ahead and type something in the text box. Looks like it's working correctly. I'm typing Steve, and since Steven and Steve, they both start with the word Steve, they are both selected. But what if I remove everything? If I remove everything, then everything is gone. Now, at this point, I do want to show the actual list. So let's see how we can fix that. When we are not really searching for something, or when we are searching for something, but we remove the text because there are no results, we don't really want it to show as empty. So we need to fix that. Now, one of the ways to fix that is to simply check if the filtered friends is empty, then we will simply assign all of them to be the filtered friends, meaning friends. So if it doesn't really give us any result, if thing that you were searching for, it doesn't exist, then we will just give you the whole thing. Let's go ahead and see if that works. So if I say Steven, you can see that there's nothing going on. Now, this may not be the behavior that you actually want, so we can accommodate that part also. So let's see what's going on now. If I search for, let's say, my name, it still shows me everything, which is not really right. It shouldn't show me. So this code that we typed in, that's not going to work. We need to find out if the search itself is empty, because that is exactly what's going on. So if the search itself is empty, then maybe we can assign it a different thing. But how can we do that? Well, let's go ahead and try it out. If the search itself is empty, meaning if you typed in something or if you type in something and you delete it, so everything, then we can say that the filtered friends becomes friends. Else, we will perform the actual search because you have given us something to work on. Now, if I go ahead and type in my name, and since I'm not in the list, it doesn't really pull up anything. But if I remove everything, then it comes back with the whole list, which is the appropriate behavior that I wanted. And now everything is working correctly. So in this lecture, you learn about how to filter an array and display it in a list. You also learn about the onChangeView modifier, which is going to get fired whenever some state changes, which in this case is simply the search. So hope you have enjoyed this. And now let's go ahead and talk about binding property wrapper. Now let's go ahead and talk about binding in SwiftUI. Whenever we talk about binding, we talk about that when your child view will be able to communicate with the parent view. So in this scenario, with the code that we have on the screen, we don't really have any child view. Yeah, you can consider the VStack to be a child view, but we're talking about your own custom child view. So let's go ahead and create one. I'm going to go ahead and create a view called light bulb view, which will be a SwiftUI view. Now you can create the light bulb view into a different file. That's perfectly fine. But just for the sake of simplicity, I'm just going to create it in the same file as the content view. Next, we're going to implement the body property. And we're simply going to say light bulb view. Now, if I want to use the light bulb view in my content view, I can easily do that. I can simply go ahead and put the light bulb view inside the VStack or even on its own. And you can see the light bulb view is getting rendered. But what if the light bulb view contains some information or some code to change the light bulb from on to off? Well, in those cases, we do want a couple of different things. We will first go ahead and use a VStack to create a light bulb. So I can use an image over here. I can pass in a light bulb. I think that's the correct spelling, and you can actually see the light bulb. I can also go ahead and make it a little bit larger. There we go. And I can also create a button. Let's say it will be called toggle. So we can toggle between different states of the light bulb. Now, when we toggle, we want to change the light bulb, the foreground color of the light bulb from right now, which is white, to yellow. So for this, I'm going to go ahead and create a state property. Is on, which is Boolean, and false. And I can go ahead and easily toggle this particular state by saying isOn.toggle. Whenever we toggle isOn, we can use the isOn property to switch the color of the image or the light bulb. So in this case, foreground color or the foreground style, we can say if it's on, then use yellow or else use white. Now, right now you can see that when we use white, it doesn't even appear. So probably white will not be a good choice. There we go, that's much better. Now if I do toggle, it turns it on. And if I toggle again, it turns it off. Great. We can even switch around the light bulb itself. Right now it's just using light bulb, but I believe there are something called lightbulb.fill, so you can use that also. Let's go ahead and do that also. Is on, then we will use an image lightbulb.fill, else by default we're just going to use a light bulb. Wow, definitely much better. But at this point, we have not really used the property or the value of the property is on in our content view. Maybe the content view itself is saying that, hey, whenever the light bulb view enables or turn on the light bulb, I need to know that too, so that I can switch between the background of the VStack. Right now, if I simply go ahead and add a background, so let's go ahead and add a background, you will see that the background is only for that particular portion. Now I can go ahead and set the frame to be the maximum width, to be infinity, and maximum height to be infinity also. And this is going to make sure that the VStack is filling all the place. But based on the background, if the light bulb is on, then maybe we want to change the background to black, or else we want to change the background to white. But how can we do that? Because the property is on is only available inside the light bulb view. So somehow this view needs to communicate with the content view that, hey, I have just updated the light bulb is on from false to true and true to false. And this is where the binding comes into play. This particular property that we created on line number 12 is a private state. This means that you cannot really access this private state from outside of the light bulb view. It's also marked with private, and it's usually a good idea to keep it private. So how can the content view access the values and also re-render itself when the light bulb view changes? So this is where the binding comes into play, and we're going to go ahead and add another property is over here in the content view, and we can call this property anything you want. I'm just going to call it is on. Keep in mind that it doesn't have to be called is on. You can call it anything you want. And in the light bulb view, we can make it so that you pass in the property. Is on, but we have to pass it with the binding. Now let's go ahead and talk about what this binding actually means. In order for this to work, we can't really use state. So let's remove the state and replace it with binding. Now at least it compiles. So what exactly is going on over here? In the content view, we created the private state. This is called the isOn property. That's a private state only available inside the content view. We are passing a binding, and that's what the $ indicates, to the lightbulb view. This means that when we change isOn, or whatever you pass in isOn, from inside the lightbulb view, then it is going to tell the content view that, hey, you need to refresh yourself. Now again, the isOn over here doesn't really have to be called isOn. You can call this anything you want. I mean, if you want, I can go ahead and change it to isLightOn, if that makes you happy. Make sure that you pass in the binding. And this is indicated by the binding property wrapper in SwiftUI. The binding property wrapper is simply saying that someone, the parent, is going to be passing in the value of, or the binding for this property called isOn. Whenever this particular property changes, as you can see is changing, then I need to also notify the parent, which in this case is content view, that that particular property has changed, so the parent can reevaluate the body itself. Now, if during that reevaluation, the parent, which is content view, is going to find out that, hey, yeah, some of the views and some of the conditions in the content view itself is dependent on isOn, then that particular view will be re-rendered. So let's go ahead and do that. I can go over here and say is light on. If the light is on, then go ahead and change the background to be black, or else change the background to be white. So if it's on, then change the background to be black or else white. Right now, the background is white. Let me toggle it. Did you see what happened? As soon as I toggle it, I change the isOn property. The isOn property is using the binding property wrapper. This means that when the value of isOn property changes, not only it's going to re-render and re-evaluate the light bulb view, but it's also going to tell the content view that, hey, that state value has actually changed, so you may want to reevaluate and re-render yourself. And we did re-render because the isLightOn property was actually used in the body. Now if I change it back, you can see that it works great. In other words, whenever you want your child view to be communicating with the parent view, you can use the binding. Binding is always passed from the parent to the child. Now, in the next lectures, we'll be learning about environment values, the environment objects. When you have a child view that is past a binding, that's perfectly fine until you have a child view and a child view and a grandchild view and a great-grandchild view. Then passing those values again and again in the constructor, it can become a headache. So sometimes you want that global state, which is just easily accessible from anywhere. And that is the job of the environment object. So in the next lectures, we'll be learning about how environment object can be used. Now let's go ahead and learn about the global state. And the global state in SwiftUI is maintained through the use of environment object. So what will be an example of a scenario where you have to use global state? Consider an application that has multiple views. So this is your top view. You have more views. And let's say that this is kind of like the hierarchy that you have. Great. Now, let's say that if this view does something and the view number 2 is saying that, hey, I want that information also. So how can we do that? How can we accommodate that? Well, One of the ways is that the parent view is going to pass in the binding to the view number 1. That binding is going to change, and then the parent view again is going to pass the binding down to view number 2 so that the view number 2 can reflect the changes. But as you can imagine, this is a lot of work. And if you have a much deeper hierarchy, then it's going to be very painful. So how can we make it better? One of the concepts in SwiftUI is of a global state. This means that you can create a global state, let's call it global state. And if view number 1, which is kind of like at the bottom, if it needs to write something or change the state, it's going to go directly and change that state. And if there is any other view that is like, hey, I want to read that state too, I want to get notified when that particular state changes, then those people or those views can subscribe to it and get the value without passing it up or down through the use of binding. Let's take a look at an example. In this example, we have already built the light bulb view, which we did it last time. But let's say that we have another struct, and that is light room view. The light room view, we're just going to go ahead and create it as a body. And in the light room view, that is simply going to go ahead and send in the light bulb view. Now again, we have to pass in the binding over here. So eventually all of this information needs to be sent back to the content view. So again, we're going to use the binding. It's on Boolean, and we can go ahead and pass the binding to the light bulb view. There we go. Now in the content view, we can replace the text view, and we can start using the Lightroom view. We can also start the binding and pass it down. Now taking a look at this example, we will have to use isLightOn. That's the binding that we have, not isOn. So over here, what we're doing is the Lightroom view is being send the binding. The Lightroom view gets the binding and pass it down to the light bulb view. The light bulb view then changes the binding. Everything works as expected, but you can already see that it's a bit of a work. I mean, you have to send the binding to the Lightroom view. The Lightroom view doesn't really do anything with the binding itself. It just sends it down to the light bulb view, and light bulb view gets the binding, and then it performs changes to the binding itself, changes the state, which reflects in the Lightroom view, which then reflects in the actual state that was being passed to the Lightroom view. So although this all works, but it's a hassle to pass down the value again and again. And it's going to get bigger a hassle if you have a much deeper hierarchy. So the way that we can solve this problem is by using an environment object. In order to use environment object, the first thing we're going to do is create a class. Now this can be anything, so I'm just going to go ahead and create an environment object with app_state. Keep in mind that right now I'm just going to use observable object because this is pre-iOS 17. Actually, even with iOS 17, you can still use that. But with iOS 17, we have some, different macros that are available that you can use. So it's observable object, and it has to be a class. Inside the app state, we can create some properties. Var is on Boolean false. And you also have to mark these properties with published. This means that whenever this property is going to set, it's going to tell all the subscriber that it has changed. Make sure that you understand that this is for pre-iOS 17. It will still work with iOS 17, but in iOS 17 there is a different way. So keep that in mind. So we have created this class called app_state. How do we use this class? In our previews, we have to inject the app state at the root object. And the reason that we inject it in the root object is so that other views that are children of content view, they will also know about the environment object. So I'll use environment object and simply inject the environment object, which in this case will be app state. Now keep in mind that this is only for the preview itself. If you're running an actual application in a simulator or on a device, you do have to inject it in a different way. So let's go to the Learn app and inject it right there. Sometimes people like to create a state object, and that is perfectly fine too. So you can do it this way, and that is perfectly fine. State object. State object means that this is a new source of truth. App state will create that. We don't really need that since we are already initializing it. And we can simply pass in the app state. So both are kind of like the same because the Learn SwiftUI app is not really going to be reevaluated anyways, so both are same. Let's go back to the content view. Now the way that we injected it over here is only applicable if you're using the previews, which we are. Now since we have injected the app state, we can get access to the app state by using environment object and then simply calling it app state, which will be app state. And now, instead of passing down these values, you can simply go ahead and change the values, the published property of the app state. This means I'm going to go ahead and remove the Lightroom view. So we are not really going to be passing anything to the Lightroom view. There we go. This means the light bulb view is also not going to get the binding. Well, if the light bulb view does not really get the binding, how can the light bulb view get access to the isOn property? Well, again, it can actually use the environment object. It will get access to the app state. And using the app state, we can set this up. So app state dot isOn, and same thing over here, app state dot isOn, and then app state dot toggle. So this time, when the light bulb view renders and it allows you to change the state, it updates the global state. Whenever the global state changes, it's going to tell all the views that are using the global state. So it's going to tell content view that, hey, global state has changed. Do you want to refresh yourself? We can remove that part and we can just start using app state now, which is the global state. So over here, just to recap, for the previews, we are injecting the environment object. We get access to the environment object. This particular environment object is app state, which is defined right here. It only consists of one single property called isOn. You can have more properties. You can even have more environment objects, meaning more observed objects. And you can inject it to the root view, which is content view, or any other view. So if I inject it over here, let's say environment object, that is perfectly fine, but I don't really have to do that. And the reason that I don't really have to do that is I already injected it in the content view. So the environment object, meaning the app state, will be available to the content view and all the children of the content view, which also includes the Lightroom view. So I don't really personally have to inject it over here if I don't want to. Now let's go ahead and run the application. So if I run the application, it works exactly as before. But one of the good things that we see from this example is that we didn't really have to pass in the binding. And that's the whole point of the environment object. Now keep in mind that in the previous examples, we were using binding. Just because you know environment object and how to use environment object, that does not mean that binding is useless. They both serve different purpose. Binding can be used if you have maybe 1 or even 2 levels deep. That's kind of fine, especially for 1 level deep. But as you get 3, 4, or 5 level deeps and you have certain objects, meaning certain global state that is required by some other views that are very deeply nested, then it is a good idea to start using environment object. So this is how the environment object works in SwiftUI. Now let's go ahead and see that how in iOS 17 and above, the declaration and usage of environment object has changed. As mentioned in the last lecture about environment object, that in iOS 17, Apple has introduced a new way of declaring your observable objects. So let me remove this first of all. This is now no longer pre-iOS 17. And in order to convert this observable object into the new implementation, the old implementation will still work, but if you want to convert it into new one, first of all, we will import observation, and we will remove this part, which is we're conforming to observable object protocol, and use the macro called observable. Apart from that, we will also remove the published. So all of these assigned properties are automatically published, so we don't have to use that. Let's go at the bottom where we're injecting the environment object. So the way that you inject your environment object in your iOS 17 and above is instead of using environment object view modifier, we're going to use the environment view modifier and simply going to inject the environment object right there. Okay, great. And how do we use it? Again, instead of using the environment object, we are going to use the environment, and we're going to specify the object type. So in this case, it will be app_state.self. So that's the one that we want. Let's go ahead and try to copy this and use it somewhere else also, right here. Now, we will also have to update that over here, right? So over here, we're going to use state and not state object. We can create the app state, that's perfectly fine, and then we can go ahead and inject it as the app state. Okay, so that is perfectly fine now. Let's go back to our content view. Okay, and let's go ahead and run this. And you can see that it still works. All right, so everything is still working. Now, one of the things that I do want to cover over here is right now we are changing the is on from the app state, and we're simply toggling it using the toggle function. Now, sometimes you want to take this property, which is app_state.isOn, and bind it to some sort of a control. Let's say that instead of a button, we have, let's call it a toggle, right? So let me go ahead and add a toggle. Toggle. And in the toggle, we can provide, let's say, whatever, status or is on. And for the binding, you are going to say app_state.isOn. Unfortunately, when you do this, it's not going to work. And the way that it works, if you were using environment object from pre-iOS 17, it will work. But in iOS 17 and above, this is not going to work, as you can already see. So whatever the properties are, whatever the things are in the environment object, in the global environment app state, it looks like you can't really directly bind to it using the elements, using the text or using other views. Because that's exactly what we're trying to do over here. What we're trying to do is we're saying that whenever I toggle between, toggle on and off, I want the isOn property to be changed. And isOn property is actually a bindable property because this class is marked with observable. This means all the properties inside the app state, which are assigned properties, not computer properties, will already be published properties. We don't have to say published anymore. Remember published? We don't really have to say that anymore because we are using observable. And whenever we use observable, this part, all the properties, assigned properties, are automatically publish properties. This observable is a macro. You can always right click on it and I'll always say expand macro to see the implementation. You can see right there. Okay, so what can we do in this scenario? Since we cannot really directly bind our UI elements or views to a state property. Well, one of the ways that Apple recommends doing that is to use something called a bindable. Not binding, but bindable. And what we were going to do is we're simply going to say app state equals to, or in this case, yeah, I guess app state is fine, and we're going to assign it to the app state. And then we can make it work. Now you can see that it's no longer, it is complaining, and we can build our application. So this bindable allows your app state, or allows, when we are working with Swift data eventually, you have a different code for it, to be binded directly to the UI elements. So that is what you can use it for. And you can also see the app state is a class. So we're using it with observable. If I go ahead and make this a struct instead of a class, it's already going to complain. If you were wondering, hey, why can't I just use a struct? Well, you cannot because you're using observable. It has to be a class. All right. So after making the change, and let's go ahead and refresh our view. So now we will see a toggle view instead of a button, and I can toggle on and off, and it works exactly like before. But this time we have binded our actual toggle property to an app state, but we didn't really do it directly. We use the help of bindable, which allows us to do that. All right, if I use it directly, if I just comment out the bindable, it's going to complain. So the way to do it is by using something called bindable, which means that this particular app state is, or whatever it is, it can be any kind of a global state or any other state, it can be binded to the UI elements. And that's exactly what we're doing on line number 29, because we are using the toggle view to be directly binding to the app state is on property. So there you have it. Now you know how to write this simple app using the pre-iOS 17 environment object part, and you can also learn about the new, which is the observable macro in iOS 17 and moving forward. Before diving into the implementation details, let's go ahead and take a look at what we'll be building in this section. So you can see that we have a screen and it's have a text box with city. Now this is all connected to the Open Weather Map API. This means I can go ahead and search for a particular weather and it's going to show me the weather. So first it goes and uses a geocoder API. It gets the latitude and longitude, and then using that latitude and longitude, it gets the weather. So you will be learning how to create two different clients, a geocoder client and also a weather client. Another thing to note over here is that the weather is always displayed in Fahrenheit. And the reason is I'm located in US where we use the imperial system. But if you use the same app in Asia or in Europe where they use different kind of system like Celsius or metric system, then you will get that information immediately, meaning your weather will be displayed in a Celsius format instead of some other format. All right. So you can see that whenever I enter a temperature, let's go ahead and say San Francisco. Here we go, 59. And if you go ahead and add a different temperature for different city, it's going to tell you the same thing. All right. Most of the temperature right now is kind of same, so that's why we were just looking at the same temperature. But let's say if I go and I can't really spell that, Pensacola, I guess. I'm probably misspelling that, but here we go, 57. Pretty cool for Pensacola also. All right. So now that you have seen what we'll be implementing, let's go ahead and get started. So now that you have seen what we'll be building in this section, let's go ahead and get started. The first thing you need to do is to go to openweathermap.org and register for an API. So create an account, that's a free account, and then you can register for API keys under My API Keys. So make sure you go over there and ask for an API key. It will be freely available to you. Make sure that you provide the correct email address also. Now, OpenWeatherMap has gone through some changes, and instead of getting the weather just by the city name, they do provide ability to get the weather by latitude and longitude. So if you go to the API link, which is right here, and if you scroll down, you will see many different APIs over here. If you want to get the current weather, you're going to use current weather data API, hourly forecast API, daily forecast 16 days, and so on. We will just be using current weather data API. So let's take a look at the API documentation. In the API documentation, you can already see that you need to pass in a couple of different things. You need to pass in the latitude, the longitude, and the API key. So API key you need to pass in for every single request that you'll be making, or else it will not work. For latitude and longitude, how do you find the latitude and longitude? So if you scroll down, you will see that they also do provide geocoder API. And the geocoder API is where you can pass in the name of the city, like Houston, Austin, Dallas, San Francisco, and get the latitude and longitude from there. So we will have to use both these APIs, geocoder API, and also this particular API for the current weather to get it to work. Now, if I go to the geocoder API, they do provide the API call. And you can see the API call is api.openweathermap.org. You have to pass in the city name, which is right here. You can pass in the state and the country code, but you don't have to if you don't want to. That's fine. Limit you can pass or you can ignore. And again, the API key is required. All right, so you have to pass those things. You can also pass a limit or ignore it. So how will this look like when you're actually using it? Right there in the first one, you can see that I am passing Houston over here. And don't use my API key because by the time you're looking at this video, my API key is already expired. So don't use that. Make sure that you have your own API key. And it does provide you the latitude and longitude right there. Now, once we get the latitude and longitude, we can plug in into the current weather API. You can see that in the URL, we are plugging in right there, the latitude, and then we have the longitude, and then we have the API key. So use your own API key. And if I use the imperial over here, then it's going to give me the temperature in Fahrenheit. You can use metrics also over there. It's going to give you Celsius. But if I simply remove that, which I'm going to do, I'm going to remove this part, then it's going to give me in Kelvin. So you can see all of these values, 283.94, all of these values are in Kelvin. We're mostly interested in this main part and the temperature part because that's what we really want, the temperature. Now we don't really want to display the temperature in Kelvin, 283.94. We want to convert it into Fahrenheit. Now you can convert it by simply going to the URL and passing in the correct key over here, key and the value, which I was doing before, like units equals to imperial. But we want to do that in our code, and we will try to make it based on user locale. So this means that if you are in United States, you will get Fahrenheit, but if you are somewhere in Europe or some other region, you will get Celsius. All right. So let's go ahead and get started. Make sure that you go to openweathermap.org, register for your free account. Do not use my key because if you're using my key, they're already expired. You're not going to be able to pull anything from that. All right. So create an account, a free account, and then you can get the key right here in my API keys. Okay, so next thing that we want to do is to implement our endpoints and our client models. All right, so the first thing we need to do is to implement our client models, or also known as DTO, data transfer objects. If you look over here, that's the one URL that's going to take in the name of the city, and you can see that I'm passing Houston, and it's going to give me information, but the most important information that I'm looking for in this case are the latitude and longitudes, because once I get this, then I can pass it to the actual service to get the weather information. So let's first create our client-side models or our DTOs where the JSON can be mapped to. So I'll go back over here and I will create a new folder. So I've already created this SwiftUI application. There's nothing there in the SwiftUI application. As you can see, it's completely blank. All the code is already written for you by default. And I'm adding the models folder. Now in the models folder, we will first try to map the response that we are getting from our geocoding service. And if you look at the response, you are getting an array, and in the array you have an object which consists of the name and the latitude and the longitude. So there are other things also like the local names, and you can see the local names are over there, but I don't really care that much about the local names. I only need the name, latitude, and longitude. So let's go to the models and create some sort of a struct, a value type, where we can map this information. So I'm just going to go ahead and call this location. And we'll create a struct. I'll call it location. It will be decodable. Now you can make this codable if you want to, but since we're not really coding anything, we're not going to be sending or serializing anything, there's no point of making it codable. So start with decodable, name, which will be string, latitude, which will be double, and longitude, which will be double. And all of these property names that I'm putting, they are exactly matching one-to-one with the name that I'm receiving from the JSON. So you can see right here, we have the name, we have the LAT, lat, and LO and long. So I'm matching it exactly like. If it was not matching, then I would create coding keys, but that is perfectly fine. So this is fine. This is going to map correctly. The other one is the actual weather. Now this is a little bit more complicated. You can see there's a lot more information is being sent from the Open Weather Map API regarding the weather. It's not returning an array, it's returning an object. That's the first thing. And there are a lot of different things about or things that are contained in this object, like the coordinates. Now we don't really care that much about the coordinates. Then we have the weather. I don't really care that much about the clear sky stuff. What I really care about is the temperature. And this is that part, the temperature itself. So we're going to only map the temperature itself. But the temperature is inside this particular key, which is called the main. So we have to create a wrapper, which is going to wrap the whole thing. Well, by whole thing, I mean only the top level part. And in that, we're going to map this. So let's start with the top level wrapper. And you can call this again anything you want. I'm just going to call it weather, but you can call it weather response or anything like that. So weather is fine. And in the weather, the first thing I'm going to do is create the top level structure. So weather response, which is decodable, and main, which will be of type weather, which doesn't exist, by the way. So this is the thing that we need to implement. Weather, which is going to be decodable, and it will have a temperature. I think that's the only thing we want from over there. I mean, if you want something else from this, like we're talking about this part, So I'm only getting the temperature itself, but if you want feels like, temperature minimum, temperature maximum, pressure, humidity, you can do that. But in our case, we only want the temperature, which is TEMP, and that's the only thing I'm grabbing from there. All right. Now, if you were like, hey, I want to grab the feels like, okay, then write this key just like that, like this, feels like. And that is going to grab that. But I don't really care about feels like. I only care about the temperature itself. So this is how we will create that. All right. So this creates our models, the location model, the weather response, which is more of a wrapper, and then the weather model. The next thing that we need to do is we need to create endpoints, meaning so that the person can make a request getting the actual latitude and longitude, and also the user can make a request with a URL getting the actual weather. So in the next lecture, we will implement our endpoints. Now let's go ahead and implement API endpoint. An API endpoint will be a simple enum that will allow us to get the URL for coordinates by the location name and then by the weather by latitude and longitude. So I'm going to go ahead and create a new group and I'll call it clients. And the reason that I'm putting the API endpoint in the client folder is that it's kind of very closely related to our geocoding client as well as the weather client that we will be implementing. So let's go ahead and add a new file and we'll call it API endpoint. So the whole job of API endpoint is to just provide endpoints to the API, just construct the URL. So we'll start with the enum API endpoint, and we'll have to start with some sort of a base URL. So let's go ahead and add a base URL, which is simply api.openweathermap.org. That's the base URL for our open weather map. And now we can create some other cases, like getting the coordinates by the location name and getting the weather by latitude and longitude. So we'll create these two cases, and then we can go ahead and create the path property. Now, the reason the path property over here is private is that we will be exposing a different function to get the actual URL. We can perform a switch on the self because self is API endpoint, which is an enum. And in the case of coordinates by location name, we are going to be passing in the city and then giving you access to some sort of a URL, some sort of a string. So you can see that I'm using over here string interpolation. I'm injecting the city name. You can use URL components if you want to. That's perfectly fine too. The other thing that you can see over here that I'm using something called constant.keys.weather API key. This does not exist, so let's go ahead and create that also. I'm going to go ahead and say utilities. And in the utilities, I'm going to go ahead and add a new file. We'll call it constants. And the whole reason of having this file is that it will simply store some constants things like the weather API key. Let's go back. So now hopefully this will be fine. The other one that we want to implement, the other case is weather by the latitude and longitude. That's the other case. There we go. Both of them contains the API key, which is the important part. Make sure that you're using your own API key. Now, since this path property is private, we do want to expose a different function like endpoint URL, where the person can basically pass in what endpoint they're looking for, which is API endpoint, and we can return you the actual URL. All right, so the first thing we're going to do is we will get the path, and that we can easily get by simply saying endpoint.path. And then we can return the actual URL, which will be a combination of the base URL and the endpoint path. Great. So this is the implementation of the API endpoint. Next thing that we want to do is we want to implement our geocoding client, which will use the API endpoint to get the actual coordinates based on the name of the city. So let's go ahead and do that in the next lecture. Now let's go ahead and talk about how we can implement the geocoding client. So I'm going to go into this and add a new file, and I'll call it geocoding client. There we go. And the geocoding client will be a simple struct because it's not really going to be maintaining any state. It's just going to be finding out the location, which will contain the name, the latitude and longitude, and returning it to the caller. So we can simply go ahead and create this as a coordinate by city function, where you pass in the city as a string, and it's going to be async throws, so async throws, and then the location. There we go. And now we can use our URL shared session to get that particular data and the response. And you can see that here we are actually using the endpoint. So once we have the endpoint, the next thing we need to do is to get the HTTP response. We can get that. If the response is an invalid response, in that case, we can throw a network error, our own custom error, which we can implement right there. Okay, so the next thing that we need to do is once we have the response and it is 200, we can perform decoding using the JSON decoder.decode. And since the geocoding API is returning you an array, we will have to use the array. We will have to say location.self and then passing in the data. We'll get the locations, and then we can simply go ahead and return locations.first. The JSON decoder does need the try block, so we can use that. There we go. And this is it. This is how we will create a geocoding client. When you pass in the city, it's just going to return you the location, which will contain the name, the latitude, and longitude. Let's go ahead and try to see if we can use that. So I'm going to go to my content view. In the content view, you can see that we currently don't really have much going on. And just for using that, we will use it in a different way, but just to see if it's working correctly, you can write a test for it. But let me just go ahead and say get coordinates. Okay. You can use the task modifier over here. We will replace that. Don't worry about that too much. We will replace that. And then we have the geocoding client, which is geocoding client. And then the geocoding client dot coordinates by the city. I'm just going to pass in the Houston over here. Try await. Try can even be this one for now. For now, we will change that. Don't worry about too much about that. We will change that. We're just trying to see if it's working correctly or not. That's it. Okay. And I guess we can simply print out the location itself over here. All right. Let's go ahead and open up our console for the previews. Make sure you select the previews. Get coordinates. And there we go. We got Houston. We got the latitude and we got the longitude. All right, so this is great. So this looks like it is working correctly. So we have tested it out. I mean, you can write a test for it, but we have manually tested it out. The next thing we need to do is to implement the weather client, which will be responsible for getting the actual weather. Now let's go ahead and implement the weather client. Just like the geocoding client, we're just going to go ahead and make a new file, and we will call it weather client. And let's go ahead and get started. So we'll implement weather client. And the weather client will have a single function where you can pass in the location and it is going to give you the weather. So the location first must be retrieved from the geocoding client so that you can get the weather. So we'll get the weather. And we're going to start with the same thing. We are going to use the URL session.share.data and we're going to use a particular endpoint, which in this case will be weather by latitude and longitude. We'll get the data and the response. We will check that if the response is good and the status code is 200. And then once that is done, we can decode it to the weather response that we are getting from the server. And then finally return the main response, which is targeting the weather itself. Great. So this is how we will implement our weather client. Let's go back to our content view. Again, keep this in mind that we are going to change this. Don't code it like this. We are going to change it. All right. So now that we have the weather client also, what if we can create an instance of a weather client over here? We'll change it. Don't worry about too much. We will change that. Weather client. There we go. Just checking right now. Nothing more. And we'll say weather client dot fetch weather by location. We can pass in the location. We'll get the weather back. Again, we will change that. Don't start screaming yet. Don't start screaming yet. All right. And we will get the weather information, hopefully. And let's see what location over here. I guess the location has to be unwrapped, right? So again, I'm just going to go ahead and unwrap it right now over here. Again, please don't worry about this. We are going to change it. We are going to change it. And if I click, there we go. I get the weather, which is 286.65 weather. So we are getting the correct weather. All right. So this is great. Now the next thing we need to do is we actually have to refactor our code. This is not going to work. And we want to display the weather on the screen. We want to update the screen to provide some sort of a text box also. Right now, we don't even have a text box where the user can enter the name of the city. So we have a lot to do. So let's perform refactoring as well as the UI design. Okay, so at this point, we have confirmed that our geocoding client as well as our weather client works correctly. So we can remove these things because we want to invoke it in a little bit of a different way. The first thing we need to do is to create two different objects, one for the geocoding client and one for the weather client. So let's go ahead and do that in our content view. So now we have two different objects. We will also create a city as a state variable so we can grab the city name from a text view. Next, we will need to go ahead and create a text view. So we'll create a text view. We can set the text field style to be rounded border. There we go. And we can use a spacer to kind of like push everything on the top. Perfect. And when you submit, meaning once you press enter in the text field, it is at this point that we will perform some sort of a fetching of the weather. Now, it's always a good idea to use, if you want to perform some sort of an async task, then use the task modifier. Previously, we were wrapping everything with the task, and you can use that too. But keep in mind that whenever you start any asynchronous task inside this task closure, that particular task does not get canceled when the view goes away. So we want to take that into account because getting information from a geocoding client and then getting information from a weather client, these are network intensive operations that we do want to cancel if the view that goes away. So on the submit, what we're going to do is we are going to set this property is fetching weather to be true, and we have defined this property as a state variable to be false. Once this is set to true, we can use the task modifier with the ID, and it's going to be looking for its fetch weather, and if, so this means that whenever if fetching weather changes, this task modifier is going to get fired. We only want to perform an action if fetching weather is true, and it is at this time that we will perform the fetch weather. So fetch weather, and the fetch weather will be our implementation that we will add into the content view. So fetch weather, there we go. We will have async. And inside the fetch weather, we will use a geocoding client first to get the coordinate by the city name. Now we can pass in any city we want over here, but the city is already in the text box, so we'll pass that. This is going to give us the location. So we'll grab the location. There we go. Try await. Once we have the location, then we can use the weather client right there, and use the fetch weather by the location. Now, since we're using try over here, we need to also use do. So let's go ahead and wrap everything with the do catch block. If there is an error, we will simply print out that error on the screen. And this is going to return us the weather information. We'll say try await also, like this. The weather is going to be some sort of a state variable that we will create. So let's go ahead and create that. Okay, so over here, we need to use guardlet. There we go. And now we can fire fetch weather. So once we are fetching the weather, after this is done, we can set the is fetching weather to be false. And we can also make sure that our city is actually clean, meaning city is empty. The final part that we want to do is to display the weather. All right. So let's go ahead and add something over here. I'm going to say if let weather, meaning if the weather is actually set, then we can display the weather. Let's go ahead and first display it. Weather dot temperature, because that's what we want to display in the end, the temperature. Let's go ahead and put in a city name. It's kind of cold in Houston, so I would like to see some cold weather. Okay, 287, which is Kelvin. Now, I don't know Kelvin because that's not what we deal in US. We deal with Fahrenheit over here. So it would be a good idea to make sure that the temperature is actually displayed in Fahrenheit, at least for me, because I'm in US. So let's go ahead and add some font size also over here and try to work on displaying the temperature in a different way. Now, one of the things that we can use is we can use a measurement formatter. So for that, I'm going to go ahead and add a new group. I'll call it extensions. And I'll add a new file. Measurement formatter. Okay, let's rename this to measurement correctly. Measurement formatter plus extension. So measurement formatter is already a built-in class that is already in your iOS framework, and we are just extending it and adding a temperature function to it. So let's go ahead and do that. So measurement formatter.temperature, it's simply going to take in the temperature in Kelvin, and whatever your locale is, by default, it is going to use your current locale, meaning where you are, and it's going to convert it into that. So we can use that. So now we can go back over here and we can say measurement formatter dot temperature, and we can simply pass in the value, which will be temperature dot weather dot temperature. And now we can go ahead and set the weather. Okay, 52 Fahrenheit in Denver. And if I say Houston, it might be a little bit colder. Okay, 57. That's good. I'm not sure where it would be actually hot weather. I mean, all of them looks like they're kind of like the same. 52 over there. San Francisco, maybe. San Francisco is 59. Okay, so we are getting the temperature from different places, and that shows that it is working correctly. Now, if you are in a different area, meaning different region, maybe you're in Asia, maybe you're in Europe, and you are trying to display the temperature, then it is going to display you the temperature in Celsius and not Fahrenheit. And the reason is that because we're using the measurement formatter, and it is automatically going to convert it into your current locale. We don't even have to provide the locale over here. I mean, even though there is a property called locale, but you don't have to provide it because it's default set to the current locale. So there you have it. We were able to utilize the new Open Weather Map API, all the new changes, and we were able to build this application. So hope you have really enjoyed this. And if you have, please take few seconds and rate and review the course. That it will be really helpful. And thank you so much. And hey, check out some of my other courses also. Let's continue with this course. Thank you. If you want to learn more about iOS development topics and elevate and accelerate your career, then check out azamsharp.school. This is one of the largest catalogs for iOS development videos. So if you take a look at all these courses, including the MVVM design pattern, you have core data course, full stack iOS development course with Vapor, and we have reactive programming, test event development, UI kit, mastering, SwiftUI map kit, reality kit fundamentals, machine learning, and much more. So you can get these courses for their individual pricing, as you can see, or what most people do is they sign up for a monthly Azam Sharp Pro membership account, which gives you access to the 22 plus courses, because I'm always working on new courses. It is around like 130 hours of content. You get digital books, downloadable resources, and much more. Another thing that I also added are the workshops. Now these are live Zoom workshops. So if you want to learn about server-side Swift using Vapor, I am hosting a workshop on March 23rd. Now this is a very hands-on workshop. You'll get a repository with GitHub, and I'll be there live doing coding, and you'll be following along. So you will learn a lot in these workshops. You'll learn about routing, MVC pattern, database integration, and much more. And look at the price of the workshop, only 50 bucks. That's not even like, no workshop is 50 bucks. So 50 bucks for a workshop, 2 to 3 hour live. You get access to me and other people who are, adding to the workshop or who are